Right now, as you drive your car, your steering wheel is lying to you. If it is pulling to the right or dragging to the left, if it feels like it is fighting your hands on a perfectly straight road, if that orange EPS warning light has appeared on your dashboard, then a dealership wants four figures from you. They want to swap a component that is almost certainly not broken. And in the next 12 minutes, I am going to give you the exact knowledge that will make that invoice impossible for them to write. This is not a workaround. This is not a temporary patch. This is the original factory-engineered solution that the automotive repair industry has spent 15 years burying inside jargon, intimidating diagnostic menus, and proprietary software paywalls. I am going to give it to you for free. And all you are going to need is a single metal paperclip sitting in a drawer somewhere in your house right now. Let me be very clear about what is happening to you before we go any further. When you walk into a dealership with a steering pull or an EPS warning light, a service advisor will run their scanner, stare at a screen, and then deliver a verdict with all the confidence of a trauma surgeon. They will tell you your electronic power steering rack has failed. They will tell you the internal torque sensors are mechanically degraded and the whole unit needs to be replaced. The quote will be somewhere between $900 and $1,500 depending on your vehicle and how much they think you earn. They will say the words proprietary calibration to explain why you cannot have this done anywhere else. Every single word of that explanation is constructed to lead you to one destination, which is handing over your credit card. And here's the fact that will change everything you think about your car and the people who are paid to fix it. In approximately 95 out of every 100 cases where that warning light illuminates and that steering pull begins, the physical rack itself is completely undamaged. The motor is fine. The mechanical components are fine. The only thing that has changed is a single stored number inside a small electronic control unit. That number is called the Zero Point Calibration, and it has simply drifted. Fixing it takes 3 minutes and a piece of bent wire. To understand why this works, and to understand why it is so effective at producing fake symptoms of catastrophic failure, we need to go back about 20 years to a decision made in engineering labs across Japan, Germany, and South Korea. The year is 2003, and automobile manufacturers are under intense regulatory and economic pressure from two directions simultaneously. Governments are demanding improved fuel economy numbers. Bean counters inside corporate headquarters are demanding reduced manufacturing costs. Traditional hydraulic power steering, the system that had been standard since the late 1950s, was suddenly enemy number one on both counts. A hydraulic system uses a belt-driven pump that runs constantly off the engine, regardless of whether you are turning the wheel or driving in a perfectly straight line. That constant parasitic load on the engine costs fuel every single mile. It also requires hydraulic fluid, a reservoir, rubber hoses, a steering rack with internal seals, and a pump that wears out over time. The whole system was heavy, expensive to manufacture, and messy to maintain. So in those labs, engineers built something genuinely elegant. They replaced all of that hydraulic infrastructure with a single electric motor mounted directly to the steering column or the rack, a torque sensor to measure driver input, and a small computer called the EPS control module to manage everything. When you turn the steering wheel, the torque sensor detects the rotational force you are applying, sends that data to the control module, and the control module instantly commands the electric motor to add the appropriate amount of assist. On a highway at high speed, the assist is minimal, giving you a firm, connected feel. In a parking lot at low speed, the assist is maximized, making the wheel almost effortless. The system is genuinely brilliant. It weighs less, it consumes zero energy when you are driving straight, and it eliminates an entire category of maintenance. Engineers at Toyota, Honda, and Nissan were legitimately proud of this work. But inside that elegance lives a vulnerability, and this vulnerability is the entire foundation of the scam. The electric motor in your EPS system does not just assist your steering when you turn. It also holds the wheel steady and counters small disturbances from road imperfections. To do this correctly, the control module needs to know one absolutely critical piece of information at all times. It needs to know where the exact mathematical center of your steering is. Not approximately center, not close to center. The precise, absolute 0-degree position of your steering rack where both front wheels are pointing perfectly straight ahead. This stored reference point is the zero-point calibration. Every calculation the EPS computer makes, every command it sends to that electric motor, is calculated as an offset from this single stored number. Now here is where the physics becomes your enemy if you do not understand it, and your friend once you do. That stored number is not permanently burned into the hardware. It is a learned, saved value, and it can drift. Think of it this way. Imagine your eyes are closed and someone asks you to point your finger directly north. You make your best estimate and hold it there. Now imagine someone taps your elbow gently. Your aim shifts by 3 degrees. You still think you are pointing north. You are now wrong by 3 degrees, and every direction you calculate from that reference is also going to be off by 3 degrees. This is exactly what happens to your EPS control module when your car hits a sharp pothole, when a tire rotation or wheel alignment is performed without resetting the calibration afterward, or when your car battery dies and is replaced. The voltage interruption can cause the module to lose its precise reference, and when it restores power, it makes an educated guess about center. That guess is often wrong by a small but critically important margin. Here's what that small margin does to you inside the cabin. The EPS module now believes that your steering is, for example, 2 degrees left of actual center when the car is tracking straight down the road. So the computer, doing exactly what it was designed to do, continuously commands the electric motor to apply a small rightward corrective torque to compensate. From your perspective as the driver, the car pulls left. You fight it. You apply constant rightward pressure. On a long highway drive, your left arm fatigues. On a wet road, a moment of inattention means the car drifts toward the shoulder. Meanwhile, the diagnostic system reads the electric motor drawing current while the car is supposedly driving straight, interprets this as abnormal motor loading, and illuminates the EPS warning light. From the outside, from the perspective of a technician who plugs in a basic code reader, this pattern of symptoms, the pull, the warning light, the continuous motor torque output, looks indistinguishable from a genuinely failing rack. And that is precisely the point. In 2009 and 2010, as the first generation of EPS-equipped vehicles began aging out of their factory warranties in large numbers, something very interesting happened inside the repair industry. Service bulletins began circulating, not to customers, not to independent mechanics. These technical service bulletins flowed between dealership service departments and manufacturer technical support lines, and they described the zero-point calibration drift issue in detail. The language in these documents was clinical and matter-of-fact. The fix was simple. A digital recalibration using the manufacturer diagnostic tool would resolve the symptom. Cost to the shop was approximately 4 minutes of labor time. But those 4 minutes were being billed at the same rate as a full rack replacement, and someone, somewhere in the chain of profit, realized that without the right diagnostic tool, the customer had no alternative but to accept the full repair recommendation. The proprietary scanner became the gate, the calibration procedure became the secret behind the gate, and the rack replacement became the product they sold to everyone who did not have the key. Here's what they never published in any owner's manual, any general service guide, or any publicly available documentation. The engineers who built these systems never intended for the recalibration procedure to be locked behind expensive proprietary hardware. They built a hardware-level diagnostic bypass directly into the vehicle. It uses the same OBD2 port that every car manufactured after 1996 is federally required to have. The OBD2 port is a 16-pin trapezoid-shaped connector. On the vast majority of vehicles, it is located under the driver's side dashboard, within arm's reach of the steering column, usually between the left knee bolster and the center console. You can find it by reaching under the dash with your palm facing upward and feeling for a firm plastic socket. On many vehicles, there is no cover. On others, there is a small, removable panel. The specific pins that matter are pin 4 and pin 9. Pin 4 is the chassis ground. It is the fourth slot counting from the left on the bottom row of the connector. Pin 9 is the vehicle diagnostic line, used in older Japanese vehicles as the primary communication pathway before the CAN bus architecture became universal. Counting from the left on the top row, pin 9 is the 9th position. Take your metal paperclip and straighten one end to about 2 centimeters of exposed wire. You do not need to strip any insulation because there is none. A standard paperclip is bare metal throughout. Bend the second end into a small hook or grip so you can hold it without your fingers bridging the connection accidentally. Before you do anything, make sure your ignition is fully in the off position. The key should be out or in the 0 position with no dashboard lights active. Insert one end of the paperclip into pin 4 and the other end into pin 9. You should feel a very slight resistance as the metal contacts the internal pins of the connector. The paperclip should bridge both contacts simultaneously. You are not sending power. You are creating a ground pathway that the EPS diagnostic circuit is designed to detect. Now, without removing the paperclip and without pressing the brake pedal, turn your ignition key to the on position. This is the position just before the engine cranks, where all your dashboard warning lights illuminate for their standard startup self-check. Hold your ignition there and watch your dashboard. Within approximately 3 to 5 seconds, you will see the EPS warning light and several other system indicator lights begin to flash in a rapid, rhythmic sequence. This is not an error. This is the confirmation signal. This rapid flash sequence means the EPS control module has detected the grounded diagnostic line, recognized the recalibration command, and has entered its factory reset routine. It is actively zeroing its reference point. The flash sequence typically lasts between 5 and 10 seconds. When it stops and the lights return to their normal steady state, the calibration is complete. Turn the ignition off. Remove the paperclip. Start the vehicle normally. The steering pull will be gone. The EPS warning light will not return. The electric motor will no longer apply phantom corrective torque because the module now has an accurate center point reference. The computer is no longer pointing at a wrong north. This is not a reset that fades over time. This is a relearned absolute reference, stored in non-volatile memory. It is permanent unless the battery is disconnected again, in which case the same 3-minute process restores it again at zero cost. Now, I need you to fully absorb what just happened. A dealership quoted you $1,200. The actual fix was a paperclip, 3 minutes, and the knowledge that the automotive service industry decided you were not allowed to have. Every single cent of that repair quote was built on the assumption that this information would remain inside their proprietary systems, behind their licensed diagnostic software, accessible only to technicians billing at $140 per hour. Japanese automotive engineers put that bypass in the hardware. It has been there since these vehicles left the factory. It was in the original schematics. The service manuals that manufacturers supply to licensed dealerships reference these calibration procedures. The information was never hidden from the industry. It was only hidden from you. The reason this matters beyond your own bank account is the scale of the deception. In the United States alone, there are approximately 12 million vehicles with EPS systems that generate warning lights or steering pull symptoms in any given year. If even a fraction of those vehicle owners accept a full rack replacement they do not need, at an average cost of $1,100 per vehicle, the math produces a number in the billions. This is not a minor inefficiency in the repair market. It is a structurally maintained revenue stream built on information asymmetry. They know the fix. They know it is simple. They built the gate, and they charge you to walk through it. Share this video right now, not as a favor to me, but as a direct act of financial protection for everyone you know who owns a car. Your parents, your siblings, your friends who are currently driving with a subtle steering pull and quietly dreading the inevitable dealership visit. This information is the exact kind of thing that disappears when enough money is at stake. The more people who have it, the harder it becomes to bury. Subscribe and turn on notifications, not because I need the numbers, but because what I am about to publish next will make this video look like a warm-up. I have documentation showing that the same zero-point calibration suppression tactic used in EPS systems has a direct parallel in modern automatic transmission adaptive learning tables. There is a 10-minute free reset procedure that dealerships are currently billing as a $4,000 transmission replacement job. The leaked internal service documents are already in my possession. The script is already written. You need to be here for that one, because the dollar amounts involved will make you physically angry in a way that changes how you walk into any service department for the rest of your life.